right, I will go ahead and get started with my introductory remarks. Welcome everyone to UXPA International's Webinar Wednesday. Thank you for coming. Today we are going to hear about designing the UX for AI. We have three great speakers for you. Before I introduce them, I know a very common question is, will this be recorded? The answer is yes, it will be recorded and it will be on the UXPA International website. I will paste that link into the chat in a little bit. Speaking of chat, the chat should be open for people. As you come up with questions, you can put them in there or in the Q&A. I will monitor those, and we will be sure to have our speakers respond to questions at the end of the presentation. So let me introduce them. We have Jason Tellner, Dr. Jason Tellner, Emily DeCicero, and Dawn Ahukana, all from IBM, various parts. Jason is a lead UX researcher within IBM's CIO, Design User Research and Data Analytics team. He has been focusing on improving the user experience of employee support applications, such as AI-embedded products, chatbots, web support, and voice interface support. Emily is a senior design manager within IBM's sustainability software business unit, and she and her team focus on creating innovative tools that leverage environmental insights and historic data to help predict weather events. And finally, Dawn is design principal and UX architect within IBM's infrastructure organization. She's fascinated by how people relate to technology, as are we all, and explores ways to deliver value at the intersection of design and technology. And her career has covered enterprise middleware, security and encryption, IoT, and cognitive and analytics systems. So we were very excited to have these three great speakers on a topic that is obviously of very high interest in this day and age. So without further ado, I will turn it over to our speakers.
Righty. And my mouse stops working. There we go. So, sorry, go ahead.
Sure. I'll just introduce us a little. Well, Josh, you did a great job of introducing us, but I just wanted to mention that our goal with this presentation, as you said, is kind of to present to help designers understand the fundamentals that drive designing for AI. So user experience in itself is, for AI is a largely undefined area, and it really needs to be addressed. The size of the AI market is huge, and if we leave it to chance, then we run a big risk. So what we're doing is we're kind of creating a tool for designers, both internal and external to IBM, that can be sort of used as a North Star when designing a UX that incorporates AI. So today we're going to give you a brief overview of why we think this work is important, all the work we've done up to this point, and kind of where we plan to take it from here. And this is just an agenda of kind of what we're going to cover. We've got a welcome and introduction section. Then we're going to go into and give you a little bit of some historic context. We're going to cover some of the IBM pillars of trustworthy AI. We're going to touch on the design guild for AI that we're all part of. Go into some of the market opportunities. We'll speak a little to the evolution of UX, and then I'm going to talk about all of the principles that we've kind of compiled, UX for AI principles, and then we'll leave you with some UX for AI resources at the end.
All right, so I'm going to get into just a bit of the history of AI and some of the user interface paradigms and computing across history. So there's three major paradigms within the history of computing. So from the birth of computers, which is kind of debatable, but most people mark it as sort of 1945, around the Second World War. One of the first UI processing paradigms was batch processing, and if people have these visions of these huge computers with these punch cards, the whole idea is you put in all your commands in one punch card, you put it in, and then you hope that you got your correct output when it came out. So basically, if there were any kind of errors or mistakes, you'd have to do the whole thing all over again. So you did everything in batch, one at a time, in the hopes of getting an output. And it really had really poor UX. If we go on to the next slide and talk about the command-based interaction. So around 1964, with the advent of time sharing, so this is where multiple users would share a single mainframe computer through connected terminals. This led to the second UI paradigm where users were using command-based interaction. So here, the user and the computer would basically take turns, one command at a time. So this command-based interaction really has been the underlying approach throughout a long period of computing history. So basically 3 generations of user interface technology. And it starts with things like DOS and Unix, to full screen-based terminals. So that was like with the traditional IBM mainframes, and then finally to graphical user interfaces. So this is, the traditional GUI for the MacBook, Windows, even your current smartphone is using this kind of computing paradigm. So the benefit of these command-based interactions compared to the batch processing is very clear that after each command is executed by the user can reassess the situation and modify it for future commands as they progress towards the desired outcome or goal that they want. Next slide. So then we move into this third computing paradigm, which is really fairly recent. And this is AI introducing this third user interface paradigm in computing history. And it shifts to this new interaction mechanism where the user is not telling them how to do something, but it's telling them what they want at the end of their output. So it's reversing the locus of control completely to the user. So if you look at something like ChatGPT, you're essentially telling it, what do you want in the end? I want a poem about, this topic. That's what I want from my final product. Or, something like DALL-E, I want an image that's going to be, of this and that. So you're basically you're basically telling it what you want in the end. Okay, next slide.
So taking a whistle-stop tour through the history of AI technology, the ideas started and evolved in the field of practice around 1930, which is almost 100 years ago, and up to about 1980. So an example would be, given a housing database with a whole bunch of information in it, highlight the best value homes.
So if we take a walk through the history of AI and we look at all the different, major periods, going from the very beginning, we'll kind of chunk this into different time periods. So we'll go up to 1980, and then we have everything after that. We'll discuss that a little later. So in the first, the beginning of the 20th century, AI was really, spoken about as science fiction. So it was very fictional. It wasn't a reality yet. And people saw this in, fictional novels and movies like The Wizard of Oz with the Heartless Tin Man, and the humanoid robots that impersonated Maria in Metropolis. So they sort of call this the golden age of science fiction from 1938 to 1956. And then by the 1950s, there was actually a generation of scientists, mathematicians, and philosophers, most notably Alan Turing, who had this concept of AI, which was sort of culturally assimilated in their minds from all this fiction. So Turing explored the possibility of artificial intelligence and suggested that humans could use their available information and reason to solve problems and make decisions. So then why couldn't machines, sort of do the same thing? And eventually this actually became a proof of concept with the logic theorist. So the logic theorist was actually a program that was designed to imitate the problem-solving skills of human beings. And it's considered by many to be one of the first artificially intelligent programs. So that's around 1955. Then we have the period of 1957 through 1974. So, a pretty large number of years. And here's where AI really started to flourish. And, computers could store information. They could become faster, cheaper, more accessible. Machine learning algorithms were also starting to improve. And people got better at understanding these algorithms and what situations to apply them to. So some early demonstrations of these included ELIZA, which I'm sure many people have heard of before, which is sort of a chatbot-based therapist, and it had natural language NLP capabilities, so it could actually interpret human spoken word. So it really, was one of the first examples of focusing towards goals and problem solving for a person. I really need to talk about Moore's law because everyone's here is probably aware of what Moore's law is, that, estimates the memory and speed of computing, that it will, approximately double every certain number of years. And why I'm mentioning this is we get to a point where it actually it catches up to what our needs are, and it surpasses it. And when we get into the year 1980, we start talking about expert systems, which mimic the human decision-making process of a human expert. So basically, a user could ask an expert in the field, and it would give sort of an analogous response to what a person would give. So non-experts could get a lot of advice from these expert systems that were introduced in 1980. But none of these events would have really been possible without sort of Moore's law and how fast computing speed and memory were accelerating. Okay, we'll go on to the next slide.
All right, so the next stage we have is between 1980 and 2006. We progressed to digitization, expert knowledge systems, enterprise content systems, expert systems, machine learning. And these were mainly built by experts who were curating not data sets. And an example of that would be now you could predict the price of a new house listing just by leveraging a bunch of features or data points.
So going back to our historical graph, so it turns out, as I was mentioning before, that the fundamental limit of computer storage, which was holding us back 30 years ago, was no longer a problem in order to make progress in AI. So as we move from 1980, which is sort of the start of expert systems, we get into some other really important developments in AI. So NavLab, which most people, maybe have never heard of, was one of the first autonomous cars that was built. Some other significant events were Deep Blue, which was one of the expert systems, able to beat Garry Kasparov in chess in 1997. So they're sort of an example of an AI system being able to outperform a human. And then we kind of move into the early 2000s, which is really where machine learning algorithms really start to take off and really start to become, more well-developed and advanced. And we'll go on to our next slide.
Okay, so we've got deep learning here. As Jason mentioned, Moore's law no longer applies, and there's now a possibility to create machines and algorithms using deep neural networks. So now you can predict the price of a new house listing. This is giving us algorithmic recommendation engines in social media. I'm sure all of you have used these in Instagram, Facebook, Twitter, and the like. Shopping sites, computer vision apps, in repair shops and manufacturing factories, optimizing production whilst reducing defective, costly outcomes. And these are now built on unsupervised learning, where AI is given, this is built on supervised learning, where AI is given a hand-picked and curated data set of examples, and the AI itself is making up the algorithms and rules that it uses for decision making.
Okay, so following up on Don, just to go back to our historical graph, so sort of around like 2010, we see some applications of deep learning and neural networks like image recognition, which uses deep learning, was becoming much more sophisticated. Some other significant events were we had IBM Watson, which beat a person at Jeopardy. The use of NLP to answer questions and provide recommendations through smartphone apps like Siri and Cortana. And one other significant event that took place in the 2010s was the open letter on AI calling for research, not so much on the actual AI, but on the societal impacts of AI. That was sort of one of the first calls to action on that. Okay, we'll go to our next slide.
So today, 2020 to beyond, we're now in our generative AI phase. With foundational models, we have hardware algorithms using unsupervised learning, which now is they're gathering a whole bunch of the data, they're determining the rules, they're determining the algorithms that are running, ingesting massive amounts of information in the form of text, code, images, audio, video. And they're providing content that's making our wildest dreams or hallucinations come true. This is the future we're designing for now. And there's also a second wave of digitization where we, people, are the actual sample data.
And going back to our graph, so this sort of phase kind of really started around 2022 in terms of where the public had access. So ChatGPT and DALL-E come onto the scene from OpenAI, and that fits nicely with our third computing paradigm, where the user is not just providing commands, and they're actually telling the AI what they want for their complete output and product, rather than giving them like the step-by-step. So okay, we're going to get past the history and move into our pillars.
Right, so just really quickly, just to give some context, I'm going to go through some key environmental and organizational decisions that we made as an organization of people. So we agreed on the following pillars of trustworthy AI, and because it became clear that the impact of this technology was going to be more than just technical, it would also have a wider social impact. And the 5 pillars are explainability. AI systems need to be human interpretable and explainable with whatever predictions and insights they have. Fairness, equitable treatment of individuals and groups. Robustness, ability to handle exceptional conditions. Transparency, ability to include and share information about how they actually got up to the decisions and how they're designed. And finally, privacy, ability to prioritize and safeguard the consumer's privacy and data rights.
Okay, so I want to talk a little bit about our Design for AI guild that we have. Today, we are sharing the UX for AI principles and resources that we think might help you in the work that you do in designing the UX for AI. So here at IBM, we actually have a large group of around 250 practitioners who have volunteered their time and expertise to contribute to this design guild. So we have a variety of tools and templates to help other IBMers create these great AI experiences. And we also have teams that produce frameworks and tools that help in many aspects of design and development of these AI features and products. So the guild is very active, and we have a lot of sub-teams within the guild. We've been meeting very often over the last couple of years. So we've made a lot of progress on these guidelines.
So, okay, let's kind of give some context here. So how much is all of this opportunity worth? There is a PwC report, and this was back in 2020, and we're now in 2024. It's about $16 trillion. That's 16 with a lot of zeros behind it. How do designers get a slice of that market cake? It's very clear that the differentiator is going to be desirable AI user experiences. However, the challenge is not just technical, it's not just social, it squarely sits in the social-technical intersection. Currently, designers at IBM are well versed in producing software and hardware experiences for deterministic solutions, because you can determine the output with the same input again and again. These UX principles were well defined in the year 2000, that's sitting on the left. And when thinking about AI, we needed to understand how we were going to come up with practices that would address the probabilistic nature of AI technology and computing, so while still providing a great user experience and having the needs, well thought out in order to be able to cater for the fact that that AI model is going to change over time. Current AI solutions are mainly focused on their technical architecture, operations, performance, not so much the user experience. And we've been working on updating and adding UX practices and principles that equip designers to become well-versed in creating desirable experiences that leverage AI capabilities. But this is not without its challenges, and this includes figuring out when, where, and how to leverage AI.
Okay, so I want to touch a little bit on the goals of the AI principles. So, one question we've asked ourselves is how might we provide user experience guidelines, principles with examples and tooling for our AI designers? So, the baseline AI guidance that we're providing is that designers can expand their craft to become well-versed, competent AI designers at IBM, and also even for collaborators, so that they can get an awareness and gain empathy and an understanding of the UX for AI design without needing to be, as deeply versed in the details of this craft. So we really have two main sort of baseline design guidance goals that we're trying to provide. Next slide.
Yeah, so I'm going to take you through the principles. We've again, like Jason and Don were saying, we've designed this set of principles and practices really to address this impact of the addition of AI on defined user experiences and what new considerations designers need to take into consideration. So the first one is AI must be human-centered. So basically, we need to make sure that the AI works well for humans, and it's important to consider a few things. One is the user's needs and goals. So we really need to clearly understand the needs and goals of who's going to be interacting with the system. Then the user experience, right? So the system should be designed with the user's experience in mind. Also human-machine interaction. So AI systems should be designed to really interact with humans naturally. And then lastly, safety and reliability. So this includes testing, validating, ensuring the system can handle edge cases, that kind of thing. The second one, simple yet powerful, can probably be said for a lot of things, but one of the most challenging aspects of AI design is keeping features out. So the fact that simplicity is actually a market differentiator is very important to kind of recognize. Our AI solutions can be made a lot more elegant simply by omitting extra things and being kind of smart about what you don't do. The third one, design for human perception. So human perception is basically how our brains interpret and make sense of the world around us. So we do this by classifying, organizing, identifying, interpreting things. And AI designers really need to understand human perception and how it works across an emotional range in order to be effective and emotionally resonant for users. Number 4, assistive automation. So it's very important for AI to provide assistive automation rather than over automating tasks. Definitely important to keep the user in control, right? We have to ensure the AI solution works to complement what our users are doing and doesn't supersede with control. Another important thing is only automating when it adds value. So really figuring out, automation is only the answer when there's a compelling reason that calls for it, like increased accuracy or speed or efficiency, but really always asking, should AI do this task? And then deciding from there. Number 5, earn trust with transparency. So any AI experience has to gain trust over time, and it does this by showing kind of a consistent pattern of value and candid transparency. So we can intentionally design for this trust by mapping out the entire user journey and kind of identifying the low points, where trust is more likely to break down, and then understanding what might be leading to that breakdown in trust. What? So number 6, always build for explainability is important. For humans to use AI to augment their decision making, they need to understand how it's built, deployed, operated. Designers really need to prioritize explainability and transparency in the AI at every stage in the process, because accuracy and performance in AI simply just aren't enough to build trust and understanding. Number 7, design for human in the loop. So strictly speaking, all you need to do to design for human in the loop interaction is to ensure that the human has the final say. But the main distinguishing feature of human in the loop is that while AI inputs are default part of the workflow, humans really remain the gatekeepers and the final decision makers in everything. Number 8 is feedback is essential and not an afterthought. Very important. Without feedback, the AI system could continue to operate in a way that is completely misaligned with the user's desired values and the outcomes, and that could certainly lead to negative consequences. So whether the feedback is human initiated or system initiated, it must be integrated into the AI to really allow an ongoing kind of course correction and improvement as it goes along. Number 9, information insights from the data. So humans work with data in 2 ways. So they search for specific information, and then they also more broadly explore data to analyze and discover possibilities. So as designers, we really need to consider the user's intent when designing information flows in their AI experiences. So it's very important to carefully design an experience with AI to manage potential biases and ensure ethical and fair use, that kind of thing. And then lastly, design for resilience. So anticipating the unanticipated. So by planning for potential failures, designers can really better understand the limitations and potential weaknesses of an AI system, and hopefully take steps to mitigate them before it becomes deployed to the real world. So given the probabilistic nature of a lot of AI systems, it's very critical to have a plan in place when things take an unexpected turn, as they inevitably can.
So a couple of resources that, oops, sorry, I don't know what happened. I will pick that up again. There we go. Sorry. A couple of resources that we thought would be useful to the audience here. There's a site that is the IBM Design for AI site, and it covers the fundamentals, talking about some of the relationship stuff that we mentioned. There's a whole set of design thinking exercises and workshops in the Team Essentials. There's also a lot of material on ethics and basically updating your skills and empathy and practices as a designer for what you would need to consider and make sure that you are advocating for your users. And there's also a conversation design system for most people who are working on chatbots. Our design system that we use for our products and our services, the Carbon design system, actually has a pattern for chatbots, which I would definitely recommend that you check out. And the resources are also listed later in this presentation. One thing that I did also want to mention is that in this journey for AI, Dr. Joy Bolomi completed a couple of groundbreaking studies which revealed how systems from Amazon, IBM, Microsoft, and Facebook, and a bunch of other people were unable to classify darker female faces, which is why she's wearing the white mask, as accurately as that of white men. So in June of 2020, all three companies announced that they would stop or pause their facial recognition products for law enforcement. And she also has a featured documentary called Coded Bias, which is available on Netflix if you have it, or at least you can go and see the trailers and previews. I would check this out because this is the journey that we're on. She's not even a designer, and this is the impact that she's had. Imagine if we could design these experiences with the user in mind, leveraging this technology to its maximum capability, ethically and thoughtfully. And thank you. Questions?
I'm actually answering one right now in the chat.
Do you wanna?
Yeah, I can actually answer it for everyone. So this was a question from Alwin Velasquez. So he said, for Jason, can you give us some insights into the different approaches to how UX differs and is similar for voice chatbots and products with AI enhancements? Thank you. So I was just writing your response. I was going to say that the modality does definitely make a big difference in terms of the type of answer you get. I know with, all the prior work I did on voice interfaces, you have to be very cognizant of the fact that, we have to hear the answer, we have to use our working memory to remember it. So it's important that responses are chunked appropriately. There's the classic Miller 7 plus or minus 2 items you can hold in memory. So any type of, voice chatbot or, Amazon Alexa, Google, has to be cognizant of that when it gives you your answer. So if it's a fairly lengthy answer, it has to, deliver it in a way that that a person could remember it. Compared to, say, a written answer doesn't need to be so cognizant on the auditory system and the limitations of that. Oftentimes in voice-enabled responses, if there's, you can't really transmit images, you can provide links. Links can also be somewhat difficult to provide via voice. So, for IT support, I would say voice could probably be pretty challenging to get support through a voice bot. It would be much better through a written chat bot where you can read things and hold them in memory better and refer back and forth to it. So I think the task is very important when you're talking about modality, and it has to be considered if it's going to be like voice versus chatbot. But I'd say the underlying similarities are really that both try to be as conversational as they can, generally end up in better types of solutions than just kind of spitting out links, or long chunks of text. That's not really like an experience or a conversational type of experience. So they are similar in that way, and they try to achieve that conversational experience, but they need to be sensitive to the modalities and the limitations of people. Hope that answered your question.
Great, thank you. We had another question just pop up. Rajesh asks, how is your experience in designing with AI for people with disabilities and diversified communities?
Is this for someone in particular or for all
It
of us?
wasn't directed to anyone in particular, so whoever'd like to talk about.
I'll make a start because I
Yeah.
think all of us have specific perspectives. I work on the what would be typically a post-sales process where you've bought a thing, now you need to use it. You need someone to help you to operate it and run it for as long as you would like or even longer. So we've got a broad audience of customers and people who are coming to us for help and assistance. So you can't assume that that group, even before you add in things like diversified communities and populations and disability, it's already diverse in terms of their needs and their roles. So you're not thinking about monolith. You're not thinking about, okay, this is the user. You have to think about their perspectives. And something that Emily mentioned, one of the things we need to get deeper into is designing for cognition. This person comes up, they're in an emergency. Even if they're usually an articulate person, their adrenaline is going, their blood is pumping, it's emergency. So a lot of things already, it's a kind of temporary disablement, if you like. And how do you get them from, okay, my heart's beating at twice the rate that it should, to, okay, let's get you, tell us what your problem is. My stuff isn't working. Okay. What is the stuff and how can we help? And then do all of that with the existing tools that we have for digital experiences, but now do that in a conversation that you're not even there and present and able to guide, but we somehow have to be able to articulate and get through that sort of awkward initiation, win people's trust, and then get them to where they need to go. So that's kind of my perspective. And then obviously for you add in the kind of businesses that people have. It could be retail, it could be a bank, it could be a whole bunch of people. And then even outside of that, you have to cater for people's lived experiences. What do they prefer? Like Jason was saying, some people prefer to have things written, or they're in a noisy environment. So voice couldn't really be an option. So you have to allow for different options and overlap and 2 or 3 or 4 ways to do the same thing, because then the choice is your end user to choose what they want to do. So that's what I would say for that. Jason, Emily, you want to add?
I think you covered it well, Dawn. I think the idea of being able to adapt is the perfect benefit of AI. So that works well when we're talking about adapting to people with disabilities or diversity, diverse communities. So I think, a lot of the stuff I work on is weather related, and we have a lot of people who need to know the weather. And it may be a matter of life and death, right? So maybe just a quick vibration of your phone isn't going to work. You need to be verbally and notified that there's lightning in the area and you have to get down off your telephone pole or whatever it is, so I think being able to have an AI system that is able to learn and adapt is very beneficial for this kind of edge cases and diversified communities.
Great answers, thank you. I do see another one in the Q&A. Before I get to that one, someone sent me one privately, and it's a short question, maybe with not a short answer, but the question is, what is the difference between a neural network and a large language model?
Okay, I can take that one, and I'm not going to try and go back on the slides because a a large language model is, if you remember those squares, is a specialization of AI technology, which is machine learning, and a lot of that was sort of hand feeding the machine. Then a deep learning machine learning model, again, the naming could have been better, means that there is a structure, and the structure that they decided to go with was a biological neuron. So now instead of one or two, you have, imagine like a whole stack of pancakes. That is your deep neural network. And there's connections all the way through and a whole bunch of math, and in order for it to be able to calculate and break down the combinations and work out what's the statistics of A following B and so on. So that's machine learning. And then you have deep stack of pancakes. So think about machine learning like a pancake, deep stack of pancakes, and then a large language model is in between each pancake. You've slathered a whole piece of, whole bit of maple syrup, because that's the data. So you're pouring in a whole bunch of, data, which is then going through and chunking through and everything. So the final thing is a stack of pancakes, neurons with all the mathematics and the data that's been poured into it in order for it to be able to then answer a prompt like, what do you do or something. So it's those three things. And the main thing with the large language model, again, using the stack of pancakes and the maple syrup, is the model basically constructed, other than the neurons, decided how much maple syrup was going to go in and ran until it no longer could break it down. So we don't actually know how they work. We just stack of pancakes, give them a bunch of maple syrup, they pour until they're ready, and then they say, okay, I'm baked. That's why sometimes you'll hear that they take months to run and train, and they cost millions and millions and millions. That's why. So hopefully that was an explanation of what's the difference between a machine learning, deep learning, and a large language model that is
I have
pre-trained.
never understood it better, and food analogies are always appropriate, especially at
So
lunchtime on the
pancakes,
East Coast.
maple
Yes.
syrup, self applied.
Thank you.
You're welcome.
We have a question from Sean Zhu, who says, what does a UX designer do in this AI era? As an entry-level designer, how can we do a better job for the product's digital artifacts?
I will stay away from my mouse. I keep pressing it and thinking.
I think that, you, and Sean, you can correct me if I'm wrong, but I think the question is along the lines of, maybe you're not an expert in AI and you're just starting your career as a designer. Where do we go from here?
I think
Yeah,
that,
I can.
oh,
Go ahead.
sorry, go ahead, Jason.
Okay, I'll keep it short. I was just going to say, I think learning a bit about the AI domain, even if it's very sort of superficial course, is always helpful. Just understanding concepts, understanding how designing for AI is different than traditional UX design. Like, what are the risks involved in AI? What are some of the pillars that we talked about even today during our talk? The things you need to consider, like trust and explainability and those sort of important facets, and incorporate that into your design. So I think that those aspects are, a good starting point. Emily?
Yep, I was just gonna kind of echo that. That's really kind of why we started to coalesce around this idea of coming up with some principles, is because that's a big question on a lot of people's minds. Is, well, in the traditional form of user experience design, I think we're all well versed in it as user experience designers. However, AI adds a bit of a wrinkle into it, and there are many other things we need to kind of now consider, especially with generative AI, right? As you've got something that is, potentially dynamic, it's changing. Users may be using it for different things than they had been using tools in the past. So really starting to kind of think about some of these principles that we've put forward, and think about if there's other ones too, that start to resonate with you, but understanding, why somebody might want to use AI, and then how to make it explainable are some of the key aspects as you're designing for an AI kind of user interface.
Yeah, I think, to be honest, even just starting with the things that the AI technology is a tool, and it has specific things that you need to consider, just like Emily and Jason said. And there are things that you know today, it just changes the way that you might do them as a designer. So for example, if you were going to embed some sort of anomaly detection, so some kind of prediction software or prediction capability in a tool that you were designing, how would you show that to the user? How would you even indicate it? How would you apply it? One of the things that I will definitely do is make sure that in the user profile, they can turn it off. There's nothing more annoying than something telling you that something is wrong. I know, let me finish doing what I'm doing. So you want to be in control of that. Think about, okay, how would that help the person to better understand what they were looking at? So those tools you already have as a designer, you're just kind of using a different lens is the way that I think about this. And like any lens, you put glasses on, then they show you some new things. And or if you think about it like photo lenses and taking photographs and learning how to see in that lens, it takes some practice. So I definitely suggest that you safely play with the technology if it's available.
Great. All right, we have another question from Owen Velasquez. He says, could you give your opinion of, I don't know if it's PI or Pi as a conversational AI, could it be a future way that machines and humans interface?
I'm not sure what pi is.
Yeah, I don't understand what that is.
Is that, yeah, is that the
So
Google?
Alwyn, maybe you can give us a little more detail. Meanwhile, we have another question from Bruna Lima who asks, how can we ensure that the user experience for AI-driven systems is intuitive and transparent while we maintain a balance between the predictive capabilities of AI and the user's autonomy?
So those are all very good questions. I think that, you know, one of the things we can do right off the bat when starting a project that we know is going to involve AI is to start to think and ask all these questions early on. Start to ask things like, why are we adding AI into the system? What is, like I said in some of the principles, what is it that we want the AI to do, and why do we need it in this experience? Is it because we want to be more efficient? What's the end goal? And then you know, in my opinion, being able to explain to a user who is using the AI why it's going to help, how it's going to help, and start to kind of pull back the curtain on what kind of magic stuff is happening in the background. It's going to allow the user to really understand the value of it and start to trust it. And you can have the best, smartest AI system, but if your users don't trust it, it's not going to be effective. So thinking of those things.
Yeah, and one thing I would add to what Emily says, the first question that I ask is, what about the person's autonomy? If somehow the decisions that you're making from a design perspective is either an assumption that you haven't validated, or you're compromising their ability to have an autonomous experience in what you're designing, then you, like Emily said, go back and ask the questions again, because that's an indicator or heuristic for you a signal to tell you that you're probably not making the right decisions, or you need to go and negotiate with your colleagues who are the product manager and developers and come up with something that would not compromise your users' autonomy.
Just to follow up on that, one of the phrases that stuck with me from your talk was asking the question, should AI do this task? And I was wondering, what are some examples of tasks you've come across that AI should not do?
Well, I think there's a line you cross, especially with personal information and things like that. So you, depending on where your AI is getting its, how it's being fed, where it's getting the information. You have to start to think about it ethically too. And are you getting personal information that you are entitled to feed this AI system, or is this something that crosses that line into being intrusive, or maybe being too automated, right? Because then at that point it becomes, you have to keep the user in the loop, or otherwise, it's not going to be trusted. So I think kind of deciding where the data is coming from and thinking about the ethical ramifications of it early on is important. And maybe that's an example of, you wouldn't want to use data that is proprietary or private in that.
Yeah, I would say there's some research that says that the impact of the decision being made by the AI, the higher the impact, the less the trust from the user. So for example, if you're using, an AI to tell you what to invest your money in, I mean, maybe that has some medium level sort of impact. But if it's something like a health diagnosis, the trust factor is going to go down, just because, humans are less likely to trust it as like a medical professional. So because there's way more impact of that. So you have to be cognizant, I think, of the impact of the answer, the solution that's being provided, and also the explainability behind it. Does it provide enough details as to the reasoning and how it actually came to that decision or recommendation that it's providing?
I also think that you touch on another project that one of our colleagues is looking at, which is the law of the instrument, or over reliance, or the law of the hammer, right? Where we already knew before AI came along that we were deferring because it was a computer, then the answer must be perfect. Now we have a computer that's having a little fun with us, right? And the answer isn't always perfect. So we've got to apply, again, some autonomy and some judgment. And it's there's a loop there, because now we're having to spend some time thinking about, okay, this is the answer that's come from the tool. What does that mean? You can't just take it as a deterministic, if I put this input, out this comes. And so there's going to be some interesting outcomes, not just in terms of the considerations, but also the impact it's going to have on us as people, but our wider society. And one of the things you asked, going back to your question about what we should not use it for, I think we shouldn't use it for abdicating the responsibility of taking a decision.
Well said.
So, if you use it to assess somebody's risk for a mortgage, you have a professional underwriter there who will also, that should be a data point, not that is the decision because the machine said so.
I completely agree. It should really be a complementary tool to a human expert. And nowadays a lot of people are using generative AI in their jobs, and we shouldn't just leave it up to the answers it provides. We should be cross-checking, validating, understanding the answer, and use it to our advantage, not just replacing the decision-making process on the part of humans. So I see it more as a tool or an aid, but not as a replacement.
And that kind of goes back to the explainability aspect. And if that is the tool, then you really do need to understand. It's generating the answers.
Excellent, thank you. So Alwyn did get back to us with more about Pi. It is a conversational AI, and I think the thing that differentiates it is it can remember users and pick up conversations where they were left off. So I think what he's asking is, could this be sort of a future way for human machine interaction?
Yeah, I'll take that just because I've done quite a bit of work on chatbots. Absolutely. I mean, right now chatbots have a capacity to have memory, so they can remember details about people. And traditionally chatbots have been very amnesic. They don't remember anything about you, which is pretty irritating, I think, with customer service, where you got to retype your whole query and provide them with all your background information every single time you go on. But I really hope that chatbots will become less amnesic and remember more details about people just in the everyday world, in customer service, IT support. I mean, it just would be such a big time saver if it did, if it's allowed to actually hold that information. If it's sensitive information, there may be restrictions around what it's actually allowed to store and remember about you. But I would hope for non-sensitive information that, eventually will become the norm. We'll remember who you are and not have to restart from ground zero every single interaction.
I'm not sure that human customer service often does a very good job of remembering my past interactions.
No,
So,
that's true. But hopefully this can be better. Yeah.
yes, exactly. All right, one final question, and this one's a bit of a doozy. I'll do my best to make it understandable. So earlier in the talk, when you were talking about the history of computing, you talked about batch processing, where you had to feed in all the commands and hope you didn't make any mistakes. Generative AI today can feel a little bit like that because you feed it a prompt and you kind of hope to get what you envisioned. So the person was wondering, are there lessons we can learn from back in the batch processing days that now kind of reapply to the generative AI days?
I mean, the batch processing was extremely, I mean, first of all, getting the data in was much more of a cumbersome interaction than what we're facing today, because you're simply just typing a query, right? So you're not having to feed these complex cards in and wait. You also have to wait a very long time to get your output. So the feedback you're getting is almost instantaneous, right? Or maybe you're waiting like a matter of seconds, right? As opposed to when you were doing this batch computing. I know from older relatives who grew up in college in the 1960s, and they were running experiments, or in the grad school in the 1960s. They would literally wait all night to get their results from, say, an experiment. They would feed in their data and wait all night to get the output. I mean, these sorts of times are not reality today. It's really, I think, a matter of seconds or maybe minutes. I mean, I've used text analysis where I could feed in literally like thousands and thousands of comments, and at most I'd maybe wait like 30 minutes to get my output. But back to your question around what can we learn from sort of the punch card era, I mean, I would say that I mean, the idea of getting it right the first time, although it's not such a big deal if you do mess up in the era of Gen AI, because it's literally going to be a matter of seconds where you see the answer and you type it in. But I think what we can learn is that ensuring that we properly check the accuracy of the answers, and we check it for inaccuracies, hallucinations, and that's the human is still going to play a pivotal role, as it did back in the punch card era. I mean, the punch card era obviously generated much more frustration around the user, because you could make one little mistake, wait all night, and then you got to do the whole thing over again.
Yeah.
Whereas now you're simply waiting like seconds or minutes, and then you may have to retype in your query. However, I don't think we should become sort of take that for granted, that sort of the time frames between input and output are so short that we shouldn't really be checking our questions and answers. I still think the thoroughness of the check and answer needs to be, basically the quality of the question and the quality at which we oversee what it's providing will determine the quality of the output we get from it. I don't think that's changed at all.
Yeah, and kind of echoing what Jason was saying, maybe build on what we learned from batches. The how now is really easy. So we should be thinking about different questions and different things to use this technology to pursue. But the flip side of that is you're gonna have to deal with the ethics, because previously we didn't have the ethical conversation because we couldn't do half the stuff. Now that we can, should we? So it's, I see it more of a an extension and building on top of what we already know, and maybe going back and revisiting some of those gnarly hard conversations that we'd had previously, and reconsidering and seeing what we can do in terms of applying social ethics, not just can we do it because the technology is there.
When we do a lot of workshopping too around like, ethics, with 3-in-a-box teams, and, unexpected consequences of doing something, and trying to plan for that ahead of time because of that.
Well, very well said, and excellent place to end. I'm sure we could spend the rest of the day or the rest of the month talking about
Yeah.
this, but we all need to get back to other things. Jason, Emily, Dawn, thank you so much for a very informative presentation. It has been recorded. It will be up on the UXPA International website in a few days. And thanks so much once again for all of your expertise and willingness to answer questions.
Thank you,
Thank you very
everyone,
much for
for
having
hanging
us.
out with us.
Guys.
So long.
Bye.